We tried to think about the most primitive information we have regarding our extraordinary experience is that I think we choose the fact that all humanity has always been born naked, absolutely helpless for months, and though with beautiful equipment, as we learn later on, no experience, therefore absolute ignorance. That's where all humanity has always started. And we've come to the point where in our trial and error, finding our way, stimulated by designed in hunger, designed in thirst. These are conscious inputs, designed in procreative urge. We have, plus an enormous amount of, as we learn later on, designed in automated processing of the interrelationships of all the atoms in our organism. We start in then with a consciousness of the hunger, giving a drive to go after, and to seek, to experiment. Man having then no rule book, nothing to tell him about that universe, has had to really find his way entirely by trial and error. He had no words, had no experience to assume the other person had an experience. He had at first very incredibly limited way of communicating. We now know human beings being on our planet for probably 3.5 million years, with, as far as we can see, not much physiological change, pretty much the same skeleton. And what we can learn of human beings in their earliest recorded communicating in an important degree, people in India 5,000 years ago, China 5,000 years ago, were thinking very extraordinarily well in the terms of anything we know about our experience, the way we've been able to resolve the experiences into the discovery of principles that seem to be operative in our universe. I'm astonished at how well the early Hindu Chinese thinker, how well he was able to process his information in view of the very limited amount of information humanity had as of that time in comparison to anything we have today. Just making a little jump on information, as humanity on board of our planet entered into what it called World War I, these scientists around the world have ways of reporting to one another officially, and the chemists have what they call chemical abstracts. The chemical abstracts are a methodical publication of anything and everything any chemist finds that he publishes information regarding it, which comes in chemical abstracts. As a world entering World War I in the 20th, what's recorded in the 20th century, is a very arbitrary kind of a counting matter. We had some 100, I think it was 100, I'm doing this off the top of my head, my memory, about 175,000 known substances, possibly almost 250,000 substances by the time the United States came in the war, known to chemistry. But we came out of World War I with almost 1 million substances known. By the time we entered World War II, we were well up into 10 million. And we've come out of it now where the figure is really getting to be astronomical. We can't really keep track of the rate at which we're discovering more. Just talk about differentiable substances, chemically distinct from one another. Those are typical of the information. Really, it's a bursting rate now in relation to I'm speaking in relation to my own life, one life and the extraordinary numbers of lives there must have been on board of our planet. That the information is in multiplying that rate during just one lifetime indicates that something is going on here right now that is utterly unprecedented, and we're in such indication of acceleration of experience as human beings, the integration of the experienced to produce awarenesses that are indicative of humanity going through some very, very important kind of transition into some kind of new relationship to the universe, I'd say. The kind of acceleration that would occur after the child has been formed in the womb, taking the 9 months, and then suddenly begins to issue from the womb out into an entirely new world. So I think we're apparently coming through out of some common womb of designedly permitted ignorance, given faculties which we gradually discover and learn to employ by trial and error. And we're at a point where I now have what would also seem absolutely incredible to generations before. I've now completed 37 circuits of our Earth, kind of zigzagging circuits, not straight around, not tourists, just responding to requests to appear here and there, to lecture at universities or to design some structure, whatever it may be. So that is in the everyday pattern that I'm circuiting that Earth. Certainly makes it in evidence that we are dealing in a totality of humanity, not the, or up to my generation, completely divided humanity, spread very far apart on our planet, where my father was in the leather importing business in Boston, Massachusetts, United States. And he imported from two places primarily, the Buenos Aires and India, for bringing in leathers for the shoe industry, which was centered at that time in the Boston area. And his mail or a trip that he would like to make to Argentina took 2 months each way. And his trips to India and the mail took exactly 3 months each way. And it was seemed absolutely logical to humanity when early in this century, Rudyard Kipling, the English poet, said, "East is east and west is west, and never the twain shall meet." They're very, very rare matter for any human being to make such a travel as that, taking all those months. There were not many ships that could take him there. All that has just changed in my lifetime to where I'm not just one of the very few making these circuits of the Earth, but I'm one of probably getting to be pretty close to 20 million now who are living a life like that around our planet, and very much the whole young world doing so. I keep meeting my students at various universities from around the world, halfway around the world again. They're all getting to be living as world people. So this is a very sudden emergence into some new kind of relationship to our universe that's being manifest. None of it was planned. There was nobody in the time of my father, my mother, as I was brought up, prophesying any of the things I just said. When the year I was born, Marconi invented the wireless, but it did not get into any practical use until I was 12 years of age, when the first steamship sends an SOS that's in distress by wireless. Just think of it. Great many miles, and the world began to know the ship was in distress, and ships began to rush to its aid. Absolutely unexpected. My father and mother would say, wireless? Such nonsense. And when I was 3, the electrons discovered, and nobody talked about that. There wasn't in any of the newspapers, or nobody's interested in electrons, didn't know where this electron was been discovered. I was brought up that the humanity would never get to the North Pole, absolutely impossible, and never get to the South Pole. And our Mercator maps didn't even show anything up here. The northernmost points were very rugged, kind of a line, but you didn't see it, know anything up beyond that. When I was 14, man did get to the North Pole. When I was 16, he got to the South Pole. So the impossibles were happening. Like all other little boys, I was making paper darts, which you could make at school. But boys must have been making them for a very long time. And we were hoping we might be able to get to flying. But the parents said, darling, it's very, very amusing for you to try that, but it's inherently impossible for a man to fly. So when I was 7, the Wright brothers suddenly flew. And my memory is vivid enough of 7 to remember that for about a year, the engineering societies were trying to prove it was a hoax. It was absolutely impossible for a man to do that. So then, not only was that radio, but when I was 23, which is what you think, I guess many in this room are not 23 yet. When I was 23, the human voice came over the radio for the first time. And that's an incredible matter. When I was 27, we have the first licensed radio broadcasting. When I was 38, I was asked to go on an experimental TV studio program in New York where the Columbia Broadcasting had 70 sets, which in various scientists and their board of directors' homes, and they had experimental programs going out, and so they didn't have any money for paying anybody. The man who ran it, Gilbert Seldes, a friend of mine, ran the studio, and so I often appeared on his program, but we don't have television operating in the United States until after World War II. So we're talking about, I was 45 when we had our first television. So this couldn't be a more recent matter. And yet, nobody thought at that time they didn't know you were going to have transistors. They didn't know you were going to have, man was going to have satellites going around the Earth. We didn't know we were going to have radio relay satellites, that we were going to be able to have programs coming out of any part of the Earth, go any other part of the Earth. Absolutely. Not one of these steps was ever anticipated by any of the others. So that having experienced that, I also have experienced living with my fellow human beings who I find no sooner has it happened than he said, I knew it all the time. I'm not one of those to be surprised. I was sort of in on it, you know. I was a little bit responsible. There is a strange vanity of man, and I think the vanity that he has was essential to his being born naked and helpless and having to make the fantastic number of mistakes he had to make in order to really learn something. And I think he'd been so disgruntled, so dismayed by the mistakes and the errors that he would never been able to carry on. He would just been absolutely discouraged. So that he was given a strange vanity to say, continually sort of make himself exempt, and that he was some kind of privilege and always in. And he was able to then quite clearly deceive himself a great deal. So I find everybody today, so getting the moon, anybody do that, that's absolutely simple and logical. Now, it is obvious and simple and logical, provided you were born, and this has happened in your lifetime. You can see how it happened. I began to realize with that rapid changing going on, which was not anticipated, that what people call natural when I was young, the natural related to a state before these great changes occurred, where we were supposed to stay, we were inherently remote from other human beings. No way you can get the other human beings. And all the customs have been developed over millions and millions of years of tribes and little communities being isolated one from the other. How you got on with one another, seeing everybody, you saw everybody a great deal all the time. The conditions that were really brought about by that constant proximity brought about human behaviors, which we have now rules, and everybody said that, the older people say that's where you carry on, that are really no longer germane to the conditions that are prevailing. And I began to realize that for instance, to me, having been born before flying for the Wright brothers, to me it was a very extraordinary matter that man could fly. And certainly his first flying was fraught with a great deal of danger. And you admired very much the people who were able to accomplish it without failing. And our first automobiles that I had, my first automobile, the automobile tires with my first car would probably blow out within 100 miles. You were stopping really very, very frequently, getting out and taking off that tire and repairing it, ways of vulcanizing it and getting back on. We didn't have the easy mounting tires we have today. It was a very great task to do it. The engine continually broke down, brakes burnt out and wore out very rapidly, so that driving a car, doing your own cranking and cleaning your own spark plugs and often taking out the spark plugs and priming it with gasoline so you get the engine going, you were very intimate with your machine. And because if you were intimate, you knew how relatively unreliable it was. And therefore, you drove with great caution. I still drive in the terms of brakes that fade out. And I allow certain distances. I find my space that I'm allowing to the next car being and inviting young people who have good brakes and assume that they have good brakes, that they can dare to drive into that spot with great safety. Now, that would be typical, really, of the difference between people born under one set of conditions and those born under others. What seems safe, what seems logical. It's a very amazing matter to me when my own daughter, Allegra, was born, the year that Lindbergh flew across the Atlantic Ocean, but flying was still a very infrequent experience for the average human being to view an airplane actually in flight. You went to air meets. You knew that there were battles of half a dozen planes over Europe during World War I. But the Lindbergh flight was great news to everybody. The biplane was still the major ship, and I was feeling my child in a baby carriage in Chicago's Lincoln Park in 1927, and she was lying on her back looking at the sky, and suddenly a little biplane went overhead. And it was a very extraordinary matter to have an airplane show up over Chicago. And I said, isn't this amazing? My daughter is born with an airplane in the sky. To her, an airplane will seem very logical. Her daughter was born 21 years ago, and she was born in New York, and her father and mother took her to, this is my granddaughter, took her to their new home on a place called Riverdale, just north of Manhattan Island, across a bridge in north of Manhattan Island to get quite high land. It was called Riverdale. It's quite high. And there was that old wooden house at about the highest point there, and a three-story house. And my daughter and her husband had an apartment on the top floor of that wooden house. Had old-fashioned glass porches on it. And my granddaughter, lying in her crib, was coming right over Riverdale. It was LaGuardia field traffic, all the westbound flights flying in the prevailing southwest or westerly winds took off right over their house, so that literally every 30 seconds my granddaughter would hear going over the roof and everybody say airplane to her. She was not surprised. The first word my granddaughter said was not Mom or Dad, but air. And the parents and uncles and aunts and grandparents would take her out in their arms onto the glass porch. She was born in the late fall of the year. The leaves were off the trees in New York. She saw, and they'd get out on the glass porch and point to the airplane, and she saw literally thousands of airplanes before she ever saw a bird. To her, an airplane in the sky was much more normal than a bird. And looking from that glass porch down, the West Side Drive of New York went by, came over the bridge and went through a little sort of valley just below their house. She saw millions of automobiles in this first year, and the children's books that she was given were of farm pigs, horses, ducks, and all the things that I was brought up with, which seemed absolutely normal to me, because the grown-ups then, these are outside the house, and they kept pointing to them. But my granddaughter had never seen any such thing. She had seen all those airplanes, those automobiles, and a pig to her was about the same as a picture of a polio virus. She saw that the grown-ups were enjoying showing it to her, so she would laugh along with them. It was absolutely pure cartoon. Now, this is the way in which the world really has been changing, and the publishers haven't caught on to that kind of a change, that they were still publishing what's called a child's book. Now, I'll grant there are plenty of people who might have been born where there still were some ducks and pigs, but it was not the prevalent condition anymore, because during following World War I, the enormous capacity to produce machinery occurred, and farm machinery was developed in a very big way, and began to do the work on the farm more readily than the human beings could with their muscle. And the people used to have to be where the food grew, or they would perish. But suddenly there was refrigeration, there was canning, the food could reach them any distance, and they weren't needed on the farm to produce the food, so people were all flowing in the city. So this, my granddaughter's experience was really the dominant experience, by far the majority experience. That she would never have seen these things in that farm book. Now, so I now assume that when people say something is natural, natural is the way they found it when they checked in to the picture. And this picture has been changing incredibly rapidly, and with the society in general going along on all the old rules of cities and customs, where you're seeing a whole lot of each other, which are really irrelevant. And so that's one reason why then the young people of our day began to see things very, very differently from the parents, and to realize that the long traditions and customs were really no longer appropriate. And it wasn't a matter of unfriendliness of a young generation with an older generation, just simply that the new generation was being born into a new natural, which was absolutely unnatural to the grown-ups. That's enough of what I'm saying to introduce the concept of there being very large pattern changes affecting the lives of human beings on board of our planet that were not in any way anticipated by any of the humans, yet they are overwhelming and would have to be really read in the terms of being evolutionary, and that universe apparently had it in universe. This was, if you were the first time you were ever a lily, you might assume that you're just going to be a seed, and not realize you're going to then grow up with some green leaves. Then you don't know, all of a sudden you're going to sprout a white, beautiful bell-shaped flower, and you don't know they're going to have stamen in it, and each of these things are a surprise. So that I think humanity as a whole is going through a great transition, which is probably just as superbly designed as is the organization of the human chemistries and the sociabilities of all those atoms of which we are comprised. And my whole thinking out loud with you from now on is going to relate to seeking for more and more of these large patterns that are operative, which get to become deprecated by human beings very rapidly because they don't like to seem to have been caught by surprise, and because of that vanity factor, not too easy to make humanity comprehend as possibly readable and significant and predict other such waves to come about. The Again, I find human beings really, the news that we now are sharing around the world, which all of the world finds disturbing, reporting, everybody around the world is aware of troubles of other people's as they never were before. They had troubles before, but they never so aware of the other people's troubles. So we have an awareness of a totality of great trouble. And I think human beings' vanity factor, making them really feel I am solely responsible for how this is going to come out, and I can then deputize my authority to one political leader, and it's up to him to really get us out, or half a dozen that we elect and expect performance, as if human beings really can master and understand in a great way that I feel they do not. I think, to me, it's been clearly manifest that we've been very, very innocent, and that we do respond, we have to respond to the environment, whatever the environment is doing. And we can only do, I say, I don't have a word for instance, artificial. I don't have a word unnatural. I say, if nature permits it, it is natural. If nature doesn't permit it, you can't do it. You may not be familiar with the fact that nature allows that, but the fact your unfamiliarity doesn't make it unnatural. And if it's unfamiliar to us, we tend to say it's artificial or unnatural. So, now, I'm going to to review 2 or 3 ways in which I discipline myself to try to get myself thinking in a little more adequate manner concern what we know of our universe and what may be going on in a larger way, and to try to get things in a little better proportion. As for instance, I would like to have a picture of some Milky Way great galaxy. May I have this picture, please? And here we're looking at an array of stars. You can see the Milky Way running through the stars. The number of stars we're looking at is about 18,000, and they comprise approximately 1/6 millionth of all the stars in our Milky Way galaxy. We now know, and we've been able to get our great telescopes trained on other galaxies and so forth. We now have taken photographs and are aware of a billion such galaxies of 100 billion stars each. My next picture, this picture of we're looking at a galaxy very far away. May I have that next picture? And we're looking at an exploding phenomena. This looks I spoke about those 100 million, a million galaxies of 100 million stars each. 99.9% of them are invisible to our naked eye, but their sizes are great magnitude. Get a little idea. Our own star, sun, is our own Earth 8,000 miles diameter, and the diameter of the sun is just 100 times that. And so our little Earth looks very tiny against that enormous big ball. But our star sun is a small star. Most of you are familiar with Orion's belt. And in Orion's belt, one of the 2 bright stars is reddish in color, and this is Betelgeuse. And Betelgeuse's diameter is greater than the diameter of the orbit of the Earth around the sun. So that's a good-sized star. So we are a little planet of a rather inferior star, which is one of 100 billion stars in our galaxy. And we know over 1 billion such galaxies. So we get an idea. Our little planet, and you and I are utterly invisible unless we take pictures of our planet coming in from the moon. When you see through the cloud cover, you can see the blue of the waters and brown of the land, but you can't make a human being. You can't even make out a mountain, let alone a human being. There's absolutely no visibility of a mountain, because the aberration of the deepest water and the 5 miles below sea level, 5 miles above to the mountaintop, 10 miles aberration in 8,000 miles is so meager that a polished steel ball would probably be rougher than that. So that we are absolutely invisible on really a negligible little tiny planet of a rather negligible star which is a member of 100 billion out of a known billion such, so multiply the billion times 100 billion, get an idea. Now, as we look at things at great distance, in this picture that I have this is of a bursting phenomena in the heavens, which looks like a tiny little light, and it keeps remaining like a tiny light, but it's such a distance, and the distances involved are so great. This particular phenomena is expanding at a velocity of 3 million miles an hour. Which is the distance between the Earth and the Sun, 92 million, so that in 30 hours, just a little over a day, this expands the complete distance between the Earth and the Sun. And yet it remains for the thousands of years we may be looking at it like a little tiny speck there in the sky. To get a little sense of the size and the deceptiveness to us that in the magnitude of the information we're really dealing in today. I'm quite confident in this is then just as far as you and I have been able to, when I say you and I mean all our fellows, the human beings have been born naked and helpless, and finally have discovered principles of refraction of light and have developed the telescope and have been able to make a sweep out. We're getting information, tiny as we are. We have information of approximate spherical sweep out of observation of a 11.5 billion light year radius, and light year is 6.5 trillion miles. So when you get to 11.5 billion times 6.5 trillion, get an idea of the distance you and I are getting information from, reliable information. We get the rate at which this thing is expanding. And through the spectroscope, we've learned about refraction of light, and through the spectroscope we're able to take the light from all those observations, and each chemical element has its unique frequencies when incandescent, and been able then to, little human beings on our planet, been able to take inventory the relative abundance of chemical elements in the sweep out of a 11.5 billion year observation. But we have that kind of capability, despite our absolutely negligible magnitude physically, that we can deal with our minds in such magnitudes and do so quite reliably. Gives a hint that the human being must have some very great significance in this scheme, because we don't know of any other phenomena that has this mind, the human mind. And because what I talk about is discoverable only by virtue of the mind. There are a great many creatures that have brains, and all the creatures that have brains disclose that the brains are always and only synchronizing, integrating a plurality of informations from touchings and smellings and hearings, and coordinating those into some composite information that tends to produce images. But the brain is always and only, as each of those senses are, dealing in each special case experience. This is the smell of that one, this is the height of that one, touch, whatever it may be. we find the mind, human mind, able to do something that the brain cannot do. So I differentiate between brain and mind completely. What mind is able to do, human mind is able to do, is from time to time reviewing the special case experiences, because they are recallable, and the brain is very good about calling them back, calling them up again. As you review a plurality of those special case experiences, from time to time, mind has intuited there's something going on, some relationship between the special case experiences that was not being predicted or suggested in any way by any of the special case experiences considered only by themselves. I just take the very extraordinary experience while we're dealing in stars of the fact, well recorded in the earliest annals of man, that he became aware of there being 5 lights in the sky, 5 of those points of light, quite bright ones, much smaller than the sun and the moon. And these 5 bright ones behaved in ways that all the other myriad of little lights did not. The other myriad of lights stayed in very beautiful constant patterns as far as human beings could see. But 5 of them moved around, and they were a little brighter than the others, and they moved around in some strange kind of way. And they became, if you kept track of them, they would reappear. And so they had some regularities about them, so that long, long ago in Mesopotamia, Egypt, Greece, good recordings were made of these behaviors of what we began to call the planets. So there were 5 special case informations that were doing, had some relationship, it seemed, because they were behaving the way nothing else behaved. So they differentiated out by this unique behavior. We have then the human beings gradually acquiring calculating capability. And I'd like to make great note of this. We will go back and talk about it in much more detail later on. But if you ever try to do any multiplication or division with Roman numerals, you find you don't get anywhere. So supposing you were intrigued by some motions or something like that, you couldn't make any calculations with Roman numerals. So that no matter how intrigued you might be by the fact that there's something going on, I'd like to know something about it, you really know where you can calculate. The Arabic numerals came into the Mediterranean world and began to supplant the Roman numerals about 700 AD. But they would use it at first entirely as shorthand for, say, instead of 3 marks of the Roman numerals, you just go like that. It's a little quicker. So they were sort of shorthand for this larger scratching. But once you realize that the Roman numerals were used entirely as scoring devices, and a man, you could have a servant who's very ignorant, but just as you station him and say, every time one of those sheep go by, I want you to make a scratch. So he kept doing this faithfully, just matching, scoring matching of experiences. The Arabic numerals, I'm quite confident, were derived from the invention of the abacus as a calculating device. And if you are familiar with the abacus, with having rods and beads that slide on them, and you can do it with 4s and 5s, there are different module systems you could use. You would then, if you're handling things what we call decimally or finger-wise, with 5, you'd have fill up a column of 5, then you'd knock them back again, empty it, and move one over into the next column. And the convention is to move the incrementation to leftward. And when you then closed out the 5 and moved and put the one over the next column to take its place of those 5, then you had an empty column. I'm quite certain that the navigators and over the great deserts, or the navigators of the sea, who did deal in the stars as the only way to give them information about where they are, probably developed the first trigonometry and the first important geometrical calculations, did then, from time to time, lose their abacus overboard on the ship or lost in the sands. But being so familiar with it, they could draw a picture of it. They could see it in their mind's eye very nicely, and they could then manipulate the concept of filling up that column and then moving over one. I'm quite certain that the Arabic numerals represented a symbol for the content of the column. And when they moved over and left an empty column, they had to have the cipher. So the Arabic numerals had the cipher. It was interesting then that the Arabic numerals were first taken over in the Mediterranean world as substitutes for the Roman numerals. The to him and so many bags of wheat to him, but you left bags of wheat and the bags of wheat and sheep-bound bags of the church, so that there was a very large take on the part of the temporal power by virtue of controlling the calculation. As a consequence, with the publication of this book explaining the way in which you position numbers, literacy was rampant, so not too many people could read it. But it became very much a threat that anybody could do their own calculation, not have to go to the authorities to do the calculation for them. So that in many of those little kingdoms throughout the Mediterranean world, it became a death penalty if anybody caught using the cipher. The word cipher has a secret connotation for this reason, because people used it. They needed to use it. I've got to do my own calculation, but if I get caught, I must be very secretive with it. Gradually, the significance of the cipher permeates society, particularly the young student world that was literate. So the students of northern Italy and southern Germany began to realize more and more the significance of that cipher and the positioning of numbers to do their own calculations. So young people's faces are less familiar than the older people's faces, so that young people could get away with what the older people can't. So with approximately 500, it was 1,200, 500 years after the Arabic numerals come into the Mediterranean world that the treatise is written. That's 1,200, and 300 years later, it is impossible to ever again enforce the prohibition against use of the cipher. And this is a wonderful date, 500, talking about 1,500, 500 years ago. And this is exactly when Copernicus comes in. Here was a Copernicus suddenly with the capability to calculate. And calculating the positions and some of the interrelationships of what we call those planets, he came to the conclusion that our Earth was also a planet and behaving in relation to the sun the way the other planets were. This opened up a completely new excitation of humanity. Remember now I'm saying, his brain getting all this special case business, and mind intuitively stimulated that there must be something going on here. I'd like to find out what it is that is going on. And suddenly we had this calculating capability, and Copernicus coming out with a very new, fantastically new idea that we were not standing still with all this show going around us, but that we were one of the planets of that sun. And we have then Tycho Brahe, very inspired by Copernicus, and man of great means, and acquired instruments for much better observation. And he had his great observer was Kepler, and Kepler then made extraordinary new, much more accurate observations of the planets, and began to be able then to say considerable. First place he discovered they were moving in ellipses and not in circular orbits. If you yourself have ever made an experiment of just drawing a circle, having a pen and a string and a pencil, you know that you have a single restraint. But if you want to make an ellipse, you have two restraints. So the fact that they were moving in ellipses indicated that there was not only some relationship to the sun, but to some other, possibly some integrated effect of the other planets. And Kepler then now had beautiful data which showed that they were a team, all right, they're all going around the sun, but they were different sizes, they were different distances from the sun, they all went around the sun at different rates, so the team was a very disorderly team. And yet he felt that the fact that they were all on one team, they must have something more about them. But now that he had his calculating capability, he then did what a mathematician can do. He said, I want to find something common to these. See, I can't, superficially there's nothing common to them. They're all different. But I'm going to give them an amount of time very much less than one orbit of the fastest orbiting. So I think, as I remember, the amount of time was 21 days. And now he knew how far they were from the sun, each one. So on the beginning of that 21 days, he's here, and then he knows the exact amount of arc in 21 days. Then he has the radius from the end of that arc back to the sun again. Makes a piece of pie shape area. He found the same 21 days. Some of them were short, fat pi, and some were long and thin pi. But because he had the actual mathematical data, he was then able to calculate the areas of the piece of pie. Extraordinary intuition must have made him do such a thing. Must have said, as long as I have the data, I might as well calculate it. And to his absolute astonishment, he found the areas were all exactly the same this given amount of time. So while there was superficial difference, I want you to try to think of yourself being the first human being, having all this stimulation going on for thousands of years, to suddenly realize that hidden in the superficial disorder was the most incredible, elegant mathematical order, absolute coordination. And he would have to reason that if they were touching each other, you could understand how gears could coordinate. But the incredible distances intervening, how could they possibly coordinate with this elegant mathematical manner? But one thing you could say about that was that they were these great distances apart, and he knew that if he had a weight on a string and swung it around his head, it was in an orbit. If he let go, it seemed to go off in a line. The fact that they were in orbits indicated there was some kind of a tensive restraint. So we really got down to that. There's a tensive restraint, and it could be that the other planets got in various positions where there was a composite of their poles to bring about this elliptical phenomenon. We have Galileo, like other brains then, terribly stimulated by experiences, but suddenly with calculating capability. So he began to measure the rates at which objects would go down inclined planes of different angles, then free-falling bodies. And he found these free-falling bodies were increasing in their rate of falling. There was an acceleration. And he found the rate at which they were accelerating was actually multiplying the number of times itself to the second power rate of acceleration. We have then Isaac Newton, enormously stimulated by all the foregoing events of all these other discoverers, and he himself also then with mathematical capability, and he had a deep drive to somehow understand that tensive relationship Kepler had discovered. And he himself then, like you and I, could swing a weight around his head, and every time he let it go off like that, then he sent it off in a line like that, but the Earth pulled on it and pulled it that way. Quite clearly the Earth was much more powerful than he was in sending it this way. Isaac Newton then evolved his first law of motion. The body would persist in a straight line except as affected by other bodies. And he said, I see this other body, the Earth, is very, very powerful. Something to do, how much they pull must have something to do with the sizes. And he then said, I am informed by the astronomers and the navigators, we have very good information regarding the interrelationships of the moon and the Earth, the tides, the three-quarters of the Earth that cover the water, how those waters are pulled by the moon, so that trillions of tons of water being lifted by the moon pull. Obviously, the pull between them is something vastly greater than my muscles are involved, so it's something to do with size here. Then Isaac Newton, having evolved his first law of motion, the body would persist in a straight line except as affected by other bodies. He then conceived hypothetically, which a mathematician can do with it, he has his calculating capability. The patterns of the heavens were very well charted by now by the astronomers and the navigators. And for any given minute of any night of the year, you knew exactly what the patterns would be, what would be in zenith over any given point. That's how you can navigate. So Isaac Newton had some very reliable patterns of the heavens to go by for a given time. So he chose a night when the moon would be in the full, easy to observe, and probably clear weather. And then he made an assumption that the Earth would be suddenly stop pulling on the moon. As in effect, he doesn't use those words, that you would annihilate the Earth. For as you have that weight swinging around your head, if you let go of it, it goes over this line. So he said, if the Earth suddenly stopped pulling on the moon, the moon would go off on a given line. So he calculated what that line would be on that night at that time. And he was able then to pattern it against the heavens. Clearly patternable line. Therefore, on that night, at that time, he then measured the rate at which the moon was falling away from that line towards the Earth. And he found the rate at which it was falling would exactly agree with Galileo's rate of falling bodies. That is, it was an accelerating rate, and moving apparently the second power, as multiplying the number of times itself. Therefore, he said, number one, we would multiply the two masses times each other to get the relative amount of interpol compared to between any other two objects. And we halve the distance between the two, will increase the interattractiveness fourfold, that is the second power. He spoke about how there's been an inverse ratio, because he spoke about going away. So if you go twice as far away, it's only 1/4 of the pull. So he had the inverse ratio of the second power, the relative proximity. There were relatively very few literate people in his day. Very few people really listened to what he was saying. But the other astronomers did pay attention. They began then to apply his hypothetical relationship to other astronomical phenomena. Gradually began to discover, always explained all the astronomical inner behaviors of these remote bodies. So we have then suddenly human mind, all these various minds of the generations, of many generations, stimulated by something going on there between that's not of. Wasn't in any one of those planets by itself at all. And we have then Isaac Newton finding this interrelationship, which has proved to be absolutely valid and holds, as we even get in the microcosm long after, when Isaac Newton didn't know we were going to get in there at all, there's no electromagnetics involved, this mass interactiveness is operative. Isaac Newton was able to say that these two apples wouldn't pull towards each other. Therefore, you and I on the planet would not tend to think about this interpull, because the pull of the Earth is so enormous, as the friction of the apples on the table prevent any demonstration of any local two bodies pulling towards each other. So one reason escape maps so long had to be these free bodies, a great remove that would have to stimulate man to think this way. Now, what I'm coming to then is that there was nothing in the moon in its geometrical dimensions, there was nothing in its chemistry, there was nothing in its electromagnetics that in any way said it was going to attract the Earth. There was nothing, the Earth had said the same. It was not until you saw the inner behavior being manifested in free space that you realized something was going on between. Now this is when, what I said, mind and mind alone has been able to discover relationships that are existing between, that are not of any of the special case phenomena. And brain is always dealing in special case. So brains are dealing in special case, and mind is dealing in discovering relationships existing between. This is then comes to the word synergy. Synergy means behaviors of whole systems, and a minimum system would be two. Behaviors of whole systems are predicted by behavior of any of the parts of the system when those parts are considered separately, one from the other. And the word synergy I found going around the world, speaking to, I've spoken to 500, a little more than 500 colleges and universities around the world. The first 300, I checked my audiences, asking how many are familiar with the word synergy, and less than 3%. And popular audience is about 1%, so it became evident to me the word synergy was not popular, but is the only word that means behavior of a whole system unpredicted by behavior of any of the parts considered only separately. The fact then that the great inner behaviors, in fact all great generalized principles discovered by science are relationships existing between that are not of the parts themselves. That's why these scientific discoveries are few and far apart, because you're always just finding relationships. And these relationships can only and always be expressed mathematically. They're completely generalizable mathematically. So I find that the universe is quite clearly these important generalized principles which we discover. A generalized principle in science is one which no exception has ever been found to the mathematics of the principle. And a generalized principle then, our brains are always dealing in each special case, and each special case is inherently terminal, finite, syntropic, physical. Therefore, brain wants to have things begin and end, and brain would like to have a beginning and an end of the universe, a beginning and end of the world. But mind then discovers principles which must have no exception, which means that they're inherently eternal, and not the kind of word that brain is familiar with. But it's implicit that they are eternal. They must have never any exception. We find then plurality of these eternal generalized principles operative. And if you become then preoccupied with the family of known generalized principles, then you become deeply impressed to realize that these being eternal, they're all concurrently operative, and none of them has ever been found to contradict any of the others. In fact, they're all found to be interaccommodative. Now, they all have absolute regularities, and the regularities are interaccommodative. When you and I use the word design, we use it to mean a complex in which the various components are ordered in respect to the one with the other. That's a design in contradistinction to randomness. There's a deliberate placement and ordering. So I'd say then, human mind is gradually discovering, if you're looking at a plurality of the generalized principles, a great a priori design of universe. And that human mind has access to the rules and the design of universe, a little glimpse of it, because we keep pulling the curtain aside, realize there's a lot more that we don't know. But it's most impressive really about this whole experience I just gave you of an Isaac Newton or Kepler is that you ask Mr. Newton what the gravity is, he's able to tell you how it behaves. I can't possibly tell you what it is because there's nothing in any data, any specification you point to that says it's going to happen. Absolutely nothing. Therefore, when you come to the great moments, the actual fact of how great generalized principles are discovered, you come to a priori absolute mystery, within which a priori absolute mystery, this most sublime and reliable relationship is manifest as existing. So to me, the more intimate you become with the actual working moments of those who made the great discoveries, the more deeply moved you are by an a priori great mystery. I'm going to have a break for a little while. I think that it's quite hot inside here, and everybody's getting fairly affected by the heat. So let's have a little air.
Quiet on the set.
Since the great generalized principles that have been discovered by science are synergetic, I'd like to just think about the word synergy a little more. And as I said, I found audiences, the university audiences around the world, approximately unfamiliar, only 3%, and 1% of the popular audience. Therefore, it's perfectly clear that the word not being popular which would tell me that people are not thinking that there are behaviors of wholes unpredicted by behaviors of parts, because if they did think there were, then they would have to find the word to express it. And the word synergy is that word. So the fact it's unfamiliar makes it quite clear to me society has become quite content that all you have to know is about parts. Society has been quite content to be specialized, feeling that the parts are all going to add up, take care of themselves. So I'd like to think a little more about that word synergy. The word is the companion of the word energy. Energy, synergy. The ergy, the work, the SYN, and the SYN of synchronization. It's the withness prefix. It's the integrating prefix, whereas the energy was the separating out, differentiating out. Now the word energy is very familiar to man because he has been then quite content to separate out. He felt that he gained it by isolating scientifically, discover. And he has discovered certain amounts by that. He got a great deal of data by isolating. But he hasn't found these great principles by the isolation. And right, energy has been a preoccupation of man, and synergy has been really overlooked. But synergy is to energy what as integration is to differentiation. Energy is differentiating out, and synergy is integrating. There was nothing in atoms per se that predicts chemical compounding. There's nothing in chemical compounds per se that predicts biological protoplasm. There's nothing in biological protoplasm per se that predicts camel and palm tree and the respiratory exchange of gases between the mammals and the vegetation. In fact, you discover that the larger complex of the universe is never being predicted by the lesser. There's nothing in chemistry of human toenail that predicts human beings. So I find then that the universe itself is synergetic. It is a great complex of generalized principles, each of which is synergetic. So that we really have a synergy of synergy. There's an exponential synergizing of the generalized principles of the universe themselves. Now, quite clearly then, the universe being complex and synergetic, if we were able then to cope with the totality, we might be able to find out about parts, and we have what I call 3 well-known synergetic strategies of obtaining important information. First is the Greek triangle, where the triangle having 6 distinct parts, the 3 angles and 3 edges. And the known sum of the angles of the triangle, 180, plus and any 2 sides known and the included angle known, you can find out, you know, half the information, you get the other half. Be able to get half that's all unknown before is a very powerful capability. We find then that you can always institute in trigonometry, you can always invent a right triangle in any triangle, because you can drop a perpendicular line to a baseline that's going to be 90 degrees. And you can divide any triangle into 2 right triangles. And with having 2 rights, you then are able, you know one of those angles is right, therefore gives you a whole lot of information right away, plus the 180 degree known. And really only have to find out 2 other items in order to be able to solve your problems with the trigonometry. Now, there was then the Greek triangle is a synergetic strategy, working for the whole, the known behavior of the whole and known behavior of some of the parts, finding out about other parts. Into the synergetic strategies comes relatively short time ago, historically, Euler. And Euler realized an extraordinary pattern generalization. Euler doesn't phrase it in these words, but I'm giving you my own phrasing of what Euler said. He said, all visual experiences can be reduced to three fundamental aspects. There are visual experiences of trajectories. Something is in motion, leaves a trail. Or I scratch, that's leaving a trail. Or I leave a deposit of amount of chalk, that's a trail. There are trajectories, and where two trajectories cross, we get a fix. That gives you a location. And if a line, two lines, a plurality of lines cross, so the same line comes back, crosses itself, and has then a perimeter, a closure, then you have areas. And he said, lines and areas and crossings or fixes are never to be confused one with the other, and all visual experiences are reducible into those three. So you look at any picture you've ever seen, and I will say it does not include the color. It could be any color. Looking at that picture, you can say, I would consider that a line, that's an outline of a face. You could decide that this is a point, a crossing and a point would be the same. You say if it's a point, it is not an area. But if the point is big enough, you think it's an area, you make a line around it. And Euler found that when you then decided what it is you're looking at in the picture, you take inventory, that is a line, that is an area, and that is a crossing. Then he said the numbers of the crossings, which he also, because lines are crossing, they're converging as they cross, therefore called a vertex, coming towards one another, indicating, working towards a point. So he said the numbers of vertexes plus the numbers of areas, if it's a flat picture on the wall, will equal the number of the lines plus the number 1. But if he said, if you recognize that a picture on the wall is a part of some kind of a polyhedral phenomena. So if I say then that the picture, I see the picture then has an edge and a back to it, and these are very, very asymmetrical polyhedra, but that whole blackboard and its wheels are such. So now, if I then deal in what I'm looking at as a polyhedron, then he said that the numbers of the crossings plus the numbers of areas will equal the numbers of the lines plus the number 2. This will be absolutely constant. Then he said if you put a hole through the system, like put the hole in a donut or coring an apple, then the numbers of the crossings or vertexes plus the numbers of areas equal the numbers of the lines. Well, this is a very extraordinary kind of a total capability now. You know a behavior of a whole. This is all there isn't any more. And if you know some of that there, you find out the others. Then we have, in chemistry, Willard Gibbs. Willard Gibbs said that crystallines, liquids, and gaseous states, that these had an interrelationship we call his phase rule, which was very similar then to the Euler. This plus this equals this plus 2. And I've now been able, as I will go on with you in the hours or days to come, I'm going to give you then the topological identification of the Willard Gibbs phase rule. That's not the appropriate time for us to do it here, but what I'm getting at is I've given you 3 grand strategies, synergetic strategies, where you know the behavior of a whole. This is everything you observe about the whole, and you know some of the parts, you find out about other parts. Now, this is a very, very powerful matter. I find that our whole educational system around the world is organized on the basis of the little child being ignorant. Assuming the little child that's born is going to have to be taught. In a sense, it's kind of empty, waiting for information to be given to it from the grown-ups. And so the little child demonstrates time and again an interest in the whole universe. The child is very enthusiastic about the planetarium. The little child asks most beautiful questions about total universe, continually embarrassing the grown-ups who have become very specialized and can't ask the great comprehensive questions. We find the child then, with his propensity to comprehend totally, really to be synergetic. The humans have this proclivity to be synergetic, and yet our education is to say, never mind down about that universe, come in here and I'm going to give you an A and a B and a C, and then if you learn that, well, I'll give you a D and E and F. You keep adding to the parts. We do what we call building up a body of knowledge, a brick on brick. And this all both perplexed me and stimulated me into thinking about how we might somehow rather reorganize our self-education. Because education is, in the end, a self-educating. The experiences stimulate, but then the significance in the experience has to be apprehended and then comprehended by the individual. And the synergetic educational system then became of great excitation to me, and I wondered how we might be able then to, it seemed logical, if you could, to start with the universe itself. Let's start with the whole, and then we'll have no variables left out. So I felt that I'd have to have a definition of universe. And incidentally, as I disciplined myself along these lines, starting almost half a century ago, I said I must never use a word that I cannot really relate to experience. I must be able to define each word that I use. And if I don't have a good definition going back to experience, I must give it up. So I said I've either got to give up the word universe or define it in an experiential basis. Now, we found Eddington defining universe. No, Eddington defining science. Eddington defining science. And he said science is the attempt to set in order the facts of experience. The raw material is experience. I found another very great scientist, and I'm quite certain that he was unaware of Eddington's statement. I could not certify this, but the man was relatively remote, and it was Ernst Mach, the physicist of Vienna. And Ernst Mach, the physicist of Vienna, is a man whose the name Mach number, when we come to ultrasonic speed, was named for Mach, Ernst Mach. Mach, the physicist, said, physics is arranging experience in the most economical order. Because the physicist has discovered that absolutely unique to nature is that nature always does things in most economical ways. There are many ways of talking about this, the principle of least resistance or whatever, least effort, but it's always most economical. However, this is not a yes, no, stop, go affair. We find, as you're going to go on with me, that there are a plurality of equi-economical alternatives optional to every event in the universe. There's a plurality of them. But as Marx said, nature will use one of those most economical, equally most economical. So the physicist then was concerned with economy of arrangement of the experiences, and Eddington, the scientist general, interested in experience, all experiences, and he didn't specify. He said arranging experiences in order. Now, a mathematician such as Boole developed a concept of mathematicians to a little further degree, where the mathematicians have been unable to find any grand strategy approach to gain information from in a logical manner. They find it expedient to then assume the most absurd condition, and then gradually eliminate the improbability of this more utterly absurd. This is a little less absurd, to get down to something that might be reasonable. At least it's a way of sharpening up this reductio ad absurdum. We have then a Boole able to introduce most not economical orders. I just want to understand. The general science might then trying to put experiences in order, but they may not be most economical. The difference between the physicist and the mathematician then would be the physicist only interested in those most economical, because those are the only ones who really correspond to the way nature is behaving. The absurd is what nature doesn't do. But it's very fortuitous on the part of the mathematician to employ such a strategy. Now, we have Einstein saying the beginning and the end is his experience. The experience becomes quite clearly the raw material of all science. And this would mean by it is experimentally evidenceable. And once you learn how it behaves, you're going to be able to repeat the experiment, and that behavior is manifest. So that I then felt that it would be very necessary to describe universe in the terms of experience. So I said, what do I mean by the word universe? I said, I must mean the aggregate of all of humanity's consciously apprehended and communicated experiences. That'd be the whole raw stuff. What else could I mean? And at first when I said that quite a few years ago, I know I myself and many others felt maybe it's inadequate. You've left something out there. They said, you left out dreams. I said, no, it's part of it. I said, the aggregate of all of our experience. We have experienced dreaming. We also experience becoming. We've experienced that the dictionary, the numbers of the words in the dictionary increase every day because it's part of our experience. We're continually discovering another facet to the information. So I can't find anything that's been really left out of the definition. And if you can find anything, tell me about it. It's already going to be one of our experiences. So that it seems to work pretty well. And having then developed this scientific definition of universe, I then said, I have a way now of dealing in totality. I know what it is. I find it very interesting that Einstein then sought and did define physical universe in contradistinction to comprehensive universe, because he differentiated between the physical and the metaphysical. And he said he was only concerned really with the physical, because the physical can be coped with experimental evidence to reproduce the experiment. But I also say that you and I do have metaphysical experiences. He defined science, rather, his physical energy. Physical is energy. Energy associative and energy dissociative, and both turnaroundable. That the dissociative could become dissociative, could become associative. That radiation could be reflected and lands and reconcentrated and so forth. So that Einstein's physical universe consisted entirely of energy. Energy associated with matter, energy dissociative as the radiation, and one transformable into the other. We have then the physical universe of Einstein being all energetic. As he said, it used to be called ponderable, that it was weighable. But we find that weighing is then the effect of a lever, and there is then gravity can pull, but electromagnetics can pull equally. So when we get in electromagnetics, we simply say that anything that is physical can be identified by moving a needle. We can get actually a physical indicator of the presence of the physical. But the metaphysical does not move needles. Now, the metaphysical experience is a very profound one. All that's going on in this room with you, between you and I, has been metaphysical. What we might call understanding is utterly metaphysical. There are no arrows. There is nothing going on to weigh or indicate really understanding. I find it a very extraordinary matter. I can see your eye physically, and your eye will communicate to me as my tongue can wag and make sounds in airwaves, which gives you some kind of words and so forth. But the understanding is not that physical. So Einstein did not try to include the metaphysical in his definition of universe, but he defined the physical universe the following way: stimulated by experiences of which had come in great prominence in his time, at the turn of the century, where he was very much impressed by what he called the Brownian movement, this absolute constant motions in the liquids. He was very impressed with black body radiation, but he was particularly impressed by the measurement of the speeds of radiation, both light and other forms of radiation, in vacuo, linearly in vacuo, and finding that they were all the same speed. Einstein, I want to identify what he thought about these stimulants that I gave you in the terms of previous thinking proclivities of humans. We have the human beings over great ages seeing smoke, seeing steam in nature, seeing metals melted out of rock. But we have a very extraordinary time when Priestley, the priest scientist, undertook to isolate fire under a bell jar, because up to this time there had been 4 mystical elements: the air, earth, water, and fire. And he felt that fire might be a chemical element, and he gave it a temporary working name. And he then set about to isolate this fire under the bell jar. And he said he was only concerned really with the physical, because the physical can be coped with experimental evidence, to reproduce the experiment. But I also say that you and I do have metaphysical experiences. He defined science about his physical energy. Physical was energy. Energy associative and energy dissociative, and both turnaroundable. That the dissociative could become dissociative, could become associative. That radiation could be reflected and lands and reconcentrated and so forth. So that Einstein's physical universe consisted entirely of energy. Energy associated with matter, energy dissociative as the radiation, and one transformable into the other. We have then the physical universe of Einstein being all energetic. As he said, it used to be called ponderable, that it was weighable. But we find that weighing is then an effect of a lever, and there is then gravity can pull, but electromagnetics can pull equally. So when we get in electromagnetics, we simply say that anything that is physical can be identified by moving a needle. We can get actually a physical indicator of the presence of the physical. But the metaphysical does not move needles. Now, the metaphysical experience is a very profound one. All that's going on in this room with you, between you and I, has been metaphysical. What we might call understanding is utterly metaphysical. There are no arrows. There was nothing going on to really to weigh or indicate really understanding. I find it a very extraordinary matter. I can see your eye physically, and your eye will communicate to me as my tongue can wag and make sounds in airwaves, which gives you some kind of words and so forth. But the understanding is not that physical. So Einstein did not try to include the metaphysical in his definition of universe, but he defined the physical universe the following way, stimulated by experiences of which had come in great prominence in his time, at the turn of the century, where he was very much impressed by what he called the Brownian movement, this absolute constant motions in the liquids. He was very impressed with black body radiation, but he was particularly impressed by the measurement of the speeds of radiation, both light and other forms of radiation, in vacuo, linearly in vacuo, and finding that they were all the same speed. Einstein, I want to identify what he thought about these stimulants that I gave you in the terms of previous thinking proclivities of humans. We have the human beings over great ages seeing smoke, seeing steam in nature, seeing metals melted out of rock. We have a very extraordinary time when Priestley, the priest scientist, undertook to isolate fire under a bell jar, because up to this time there had been 4 mystical elements: the air, earth, water, and fire. And he felt that fire might be a chemical element, and he gave it a temporary working name. And he then set about to isolate this fire under the bell jar. And he weighed the items that he was going to ignite, and then ignited them. And when the fire was over, they found that the products under there weighed more than the weight of what they'd put in. We have Lavoisier explaining what had happened in the following manner. He said that they had not weighed the air under the jar. Up to this time, all the chemical elements been known to human beings were metals. They were iron, copper, silver, zinc, so forth. There were 11 of them, and they're very easy to identify. For Lavoisier to say that the nothingness under the bell jar consisted of plurality of invisible chemical elements, and that one of them is separated out and joined in with the other inputs of the fire, separating from the other, and he gave it the name oxygen. But this is, to me, one of the most extraordinary metaphysical jumps in history for a human being to assume that the non-metal nothingness consisted of plurality of somethings, and something so fundamental as to be actually rated as elements. It was extraordinary conceptioning. He then went on to show this exactly, the oxygen joined with the mercury, mercury oxide. He showed that what we call iron ore was something, when the oxygen are joined, you take the oxygen away and there's your iron. He went on demonstrating this oxygen joining, so that combustion really was oxidation. So we have then Lavoisier's explanation then enlightened all those who'd ever had an experience really about metallurgy. You'd had good luck in having fire and melting metals out, but suddenly it gave chemical controls to metallurgy. It also explained what combustion was. It also explained what steam was, because there's water vapor, where he had the associating of the oxygen. We have out of this, you could not have avoided inventing the steam engine out of the new mental and atmosphere of science. And the steam engine came along very shortly. And with the steam engine, the masters of the water-ocean world, 3/4 of it covers water, with the lands all divided, and the men who had enough power to command the carpenters and the metal workers and so forth, produce a ship and build a great ship, having developed this design of it through eons of experience with the sea, gradually learning what did constitute a big, good, adequate ship, be able to send it to great distances, integrate the resources of Earth, which were very different in the different parts of the world, bring about synergetic interaction of this in one place with another. And suddenly what was at home and didn't seem to have any value at all, suddenly has a very great value. Synergetic effects began to produce extraordinary wealth, so the masters of the water-ocean world that suddenly had steam and didn't have to wait for wind in their sails outperformed completely the people who still were just waiting for wind in their sails. We have then the masters of the water-ocean world of great wealth, incredible wealth, saying, you scientists, up to this time, energy had just been some kind of a god. Some countries had several kinds of energetic gods, some of speed and mercury, whatever it may be, but they're just gods. And suddenly you have that energy coming through a pipe with a valve, and you turn it on to do this extraordinary work. And what other kind of capabilities do you scientists have? This is the first time science really came into very important patronage by great wealth. This really brought about the Royal Society and other scientific organizations in the various competing countries of Europe, see who's going to control that water trade. So the scientists, then, giving this money to the scientists, they've been given money, developed then, they identified energy uniquely with the heat, with the fire. Therefore, they developed what they call thermodynamics. And with the thermodynamic scientific researching came the great second law of thermodynamics, discovering that all local systems always continue to lose energy. This phenomenon, entropy. And the energy is given off, may be orderly, have been given off in an orderly way in respect to that particular system, but the rate at which it's being given off by another system is another periodicity, and so the two coming together do not necessarily synchronize, so they seem to be producing randomness and disorder. And right, incidentally, I found it very interesting to look up the first law of thermodynamics as formulated in England. It was that the unit of measure of energy should be the British thermal unit, BTU. It's a highly political first law. And the second law was then about entropy. Now, we have the time of Newton, so far as the scientists knew, we had instant universe. And Newton thought of time as a quality permeating all universe at exactly the same rate. So that scientists said, as the clouds get out of the way, they're the stars, the instant stars. There had been a great astronomer, Romer, who, to explain certain astronomical phenomena that he observed, had to assume that could be that light also had a speed the way sound has speed. And Romer's calculations regarding this were very extraordinary. They come in really very close to what was found out experimentally when man on board our planet in vacuo did then, actually with mirrors, develop the speed of light experiments. But the scientists were not thinking Romer's way at all. Scientists in general were thinking instant universe. And because the universe was instant universe, then it too was a system. And with the great second law of thermodynamics, then the universe itself must be losing energy. Therefore, the universe is running down. This is the very essence of classical conservatism. The people who thought they were being well informed by science, that the universe somehow rather had a big bang. And Isaac Newton also, in his first law of motion, said, I gave you a body persists in a straight line, but his first phrase is, a body persists in a state of rest or in a line of motion, except as affected by other bodies. To Isaac Newton, at rest was norm, and all the motions were abnormal. But somehow or other, somebody had this big bang, and the universe is going to expend its energy, and anybody expends it is just going to bring us all to rest a little quicker than rest being death, and normal. It's quicker than death. We have then, in view of what I've just said to you, Einstein being informed that radiation did have a speed, and the astronomers employing this right away, discovering that it took light 8 minutes to come to Earth from the sun. And I'm going to use items that Einstein did not use, but you're very familiar with the Big Dipper, the Big Bear. And we go in, the first star on the end of the handle of the Big Dipper, you're seeing a live show taking place 700 years ago. Excuse me, 75 years ago. If we go into the next star, at the turn of the handle, you're seeing a live show taking place 100 years ago, and getting one more star, and you've got a live show taking place 200 years ago. These are anything but on the same blackboard, because 100 years difference at 6.5 trillion miles each year. You've got an incredible depth of observation where the brightness makes it seem to be akin in that pattern. Anyway, then you look at Andromeda, and you can see the few little sparkling lights of a whole galaxy there. And you're looking at a live show taking place 1 million years ago. It takes exactly 1 million years for that light to get here. Come back again to looking at Orion's belt and the Betelgeuse and the other bright star. One is a live show 1,500 years ago, another 1,100 years ago. So Einstein said the universe is an aggregate of non-simultaneous and only partially overlapping energy events. Each one of these great energy events, each one has its own duration. They have their beginnings and their endings. So we have then this, to him then, the physical universe was an aggregate of non-simultaneous and only partially overlapping energy transformation events. Now, this is a very interesting kind of a definition, because it is also the definition of what you and I would call scenario. In a scenario, we have a man born, and then he gets to be daddy, and he has children, then he gets to be granddaddy. He overlaps the grandchildren, and he dies. There's introduction of a life, and it blooms, like there's a star the same, and the star has its duration. So there are beginnings and endings of these local energy systems. But the energies, Einstein said, I don't think that in this non-simultaneous universe, that the energies that are being given off by this one might be associating elsewhere. And he said, I see on board of our planet this little child is not entropic. This little child gets to be a bigger child, doesn't deteriorate, doesn't come apart. There seem to be organisms where there's a growth, and the little sapling gets to be the big tree. So I can see then later on when it begins to shrivel and shrink, and it disappears. There's an overlapping. These energies, then he said, there was another great scientist, Boltzmann, and Boltzmann had the feeling, the concept intuitively, that energies then pulsed in our universe. You and I are familiar with our weather, where we give the weather in the terms of high and low pressures of the atmosphere. And we find that the lows are always exhausting the highs like a vacuum cleaner till they become full, they become the new high and new other lows elsewhere. So Boltzmann had the idea of exporting and importing, that one place becomes exportive, then find exhaust, and some place was importing all the time, so there's a pulsing of the universe, but the energy is not getting lost. So Einstein said, in contradistinction then to conservatives who thought the universe was entropic and nothing else, therefore the universe was running down and coming apart, Boltzmann and Einstein then think in the terms of, could be that the energies dissociating here are associating there. And so out of Einstein's expression of that powerful working hypothesis, had came very much greater attention to energy accounting. And we have then, as of this century, science having to say there was no experimental evidence of energy either being created or being lost. We do have the word in science, in physics, of annihilation. And many of the words used by the physicists are ill-chosen, I find. As, for instance, the physicist talks about particles, and he says, I don't mean about anything at all. This is just an event. But he's so used to little something being called a particle, he calls it a particle. So I find it's ill-chosen for him to use the word annihilation. His annihilation is a following kind. I have one rubber glove. There's only one rubber glove in the universe here. It's on my left hand. But I start stripping it off my left hand, and finally I pull it off like that, just gradually rolling it off. And suddenly it's off my hand, but now the left hand, it fits the right hand. And so there's the right hand now. You have a right hand, and then the right hand gets annihilated and has the left hand. One is convex and assembled and focal, and the other is simply, for the moment, invisible. This does not make it annihilated. And all the annihilations that physics has are of that character. That is, they are reinstatable. You can go from the positive to the negative. So I have Einstein's thinking and instituting way of thinking, which now, as of this point of the 20th century, makes it really quite clear, as far as experimental evidence goes, universe is eternally regenerative. Now, we have, as Einstein said, each of the energy events. Again, we had this beautiful, the photon. We'd gone down to Planck, we'd gone down to a minimum energy package. And it's a finite package. And he said, absolutely discontinuous from the next package. So he said, the universe is an aggregate of finite. Therefore, the total is finite. An aggregate of finites is finite. But you and I tend to say the proclivity of man is to say the finite is viewable, it is seeable, conceptual. Einstein's definition, which I said comes in the category of scenario. He didn't call it scenario. There have been other scientists who spoke about it as serial universe and so forth, meaning scenario. There was a very, very fascinating English scientist, philosopher, James Dunn, who wrote this serial universe. Now, scenario, what you think about, is an aggregate of frames. And there's nothing in the single frame caterpillar that tells you it's going to be butterfly. There's nothing in one single frame butterfly that tells you the butterfly can fly. You have to have a whole lot of frames of butterfly changing in relation to the environment to realize it's flying. You find that in scenario universe there's no meaning whatsoever until you get a great many of the special case experiences, and there's a little intuition of some relationships going on here. That's why the scenario is so fascinating, because you feel you're looking for those relationships all the time that are being increasingly suggested as probably present as one event after another. Now, we have then a scenario universe is then non-unitarily conceptual. Single frames are unitarily conceptual. So the universe is defined by Einstein as non-unitarily conceptual. So we have him, and it is finite because it's an aggregate of finites, and it is eternally regenerative, yet it is non-unitarily conceptual. So when you find yourself asking yourself the question, having heard that the astronomers just found a further out star, when you say, I wonder what's outside, you're asking a sculptural question, a single frame. The outside means that you do have a picture, a single one. And that's like asking, which word is a dictionary? Is a meaningless question in the terms of scenario universe. Once you realize what it was Einstein was really introducing here. So we have aggregates of finites. Now I felt that I could expand Einstein's scenario physical universe to also include my metaphysical experiences, because all of those always begin and end. My information stimulus from the brain are always terminal. So all my inputs are finite. So I said, I'm going to define physical and metaphysical universe, which I'd like to do now if I can, so in order to be able to start with the whole, is then, I said, aggregate of all humanity's consciously apprehended and communicated experiences. You communicate yourself or to the others, but the experience is not in any way, it has no meaning until we actually try some kind of communication with it. That is its beginning, is a communication. So it is a communication. The experience is a communication. So I said, I think I could combine the metaphysical and the physical by saying it is then the aggregate of all humanity's consciously apprehended and communicated experiences, which are an aggregate of non-simultaneous, only partially overlapping events, both metaphysical and physical, energetic and as well as metaphysical, weightless. So therefore I said, I see then universe, each one of those metaphysical experiences always begins and ends. Our experience is that way. It's the nature of the special casing that they are terminal. Therefore I said, they too are an aggregate of finite. So the universe has to find, both metaphysical and physical combined, is finite but non-unitarily conceptual. So I said, what is then conceptual? And what is thinkable? This brought me then to, I'm now pursuing a grand strategy of having been able now at least to get to a definition of universe. So I got a lot of actual inputs about what it is, knowing its behavior, the whole, what the whole is, and I'm going to get learning if I can about some of the parts. Now, or what other parts do I know something about? Well, I come down then to this very extraordinary phenomena you and I call thinking. Throughout the whole of my thinking out loud with you, you're going to find that I always come back to experiential base. I don't deal with any axioms. I don't say anything is self-evident. I don't say anything I believe. I can hypothesize that this may be what it is, the explanation of what it is we're experiencing. But I have to say that's a guess. It's an informed guess. But I'll always be dealing in an experiential strategy, and I'm now doing everything I can to understand how we can develop a synergetic grand strategy of approach to problem solving by human mind. So I said, what is it that I am personally conscious of doing when I say I am thinking? I'm not saying thinking may be a bright light suddenly. We often hear people say, yeah, it's a bright idea. I say, what am I conscious of about it? And as I become really fairly well disciplined in identifying what it is I am experiencing. Now, I call your attention to a common experience of all of ours, which is, we say, what is the name of that beautiful blonde tall boy, remember? And he did so and so, so yeah, great. His name is at the tip of my tongue, but it doesn't come right away. And both of us forget we said it, and then tomorrow morning you're very busy with something, in comes your name, Tom Turner, whatever, and you're a little annoyed at the thing. But what we do is we both experience that when we ask ourselves questions, we have a mechanism that goes back and gets the answer. it may be quite difficult to retrieve, may be hidden under a lot of other inputs, but it can be, we have this mechanism that does it absolutely and inexorably. That's a mutual experience. That's one reason why we remember it, because we can check up with each other. It did happen. But we have a solo experience. And I also have learned from doing what I'm doing, thinking out loud, and being on the stage many times with large thousands of people out there. A word doesn't come to me quite right away because I'm doing that thinking out loud, and I have to pull out those word tools that I've gradually learned to employ. And one comes so slowly, and I need to explain what it is, and I find I can get around it by using quite a few other words to inform you what I'm thinking about. But then just as I'm getting out that way, then suddenly the right word comes to me. I find that there are lags and recall rates, which we would not really identify because that name thing seems to come back tomorrow or sometime later on, sometimes today. But such big lags, we haven't been able to say that there's any given identifiable periodicity of lag, a length of lag. However, I've learned that the words that I'm standing on the stage needing, they're rather frequently used words, and every word I use has little lag, and some of them a little longer lags. I find the people who are not used to thinking about what it is they're doing when they're thinking and talking tend to go in between, really giving a periodicity of the lag. Now, the point is that I've discovered there's a plurality of lags and rates of recalls, and some of them are really very short, particularly these ones in relation to the word tools. And the names take longer because the names used to be names of functions, descriptions of Smith was smiting, and the miller was milling. So you could see that by your experience. It came to very, very quickly. But now when you say miller, he's not doing milling. And it gets to be then just a sound pattern. Smith is an area of sound, and it's a graphing. And so we only have certain amount of memory cubbyholes for this kind of non-functional pattern. And so they get buried very deep like magazines, so it takes a long time to go down and pull under that stack, and because that cubbyhole's been filled up just vertically now. Now, coming then to the idea that there are lags and rates of recall, and that there is an inexorable searching that is initiated when you ask yourself a question. Well, I said it to you, it's different, but I've asked myself, so I'm going down the street and I say, what is the name of that tree? My mother today gave me the name of that tree. I haven't seen one for a very long time. And then your attention is called to something else. Some friend waves from a car and you have to go on. You ask yourself questions all day long like that. So when you're trying to go to sleep sometimes, in come maple trees and all that, you wonder why these things keep coming in. And because there's no identified lag of different types, they don't come back on schedule that really makes it possible to say, yes, I asked myself that question 3 hours ago. And just look at my clock, sure enough, it's 3 hours. We don't have that kind of scheduling. So there's a heterogeneity to the rate of recall that does not make us tend to pay much attention to this. We just say, I'm a little slow, or we use such words as that. Now, I've now discovered what it is that I do when I say I am thinking. I find that I become spontaneously preoccupied. I don't do that deliberately. I've suddenly realized that's something I've been thinking about quite a lot. I've put off time and again. I really would like to think that out. So I say I'm now going to accommodate my really pursuing. There's some important relationship going on here, but if I only take a little time, I'm going to find out what understanding means. I'm finding the relationships. I like to understand what's going on here. So what I do consciously then, when I say I'm thinking, is that my conscious part is keep coming messengers with maple trees and things, and I say, that's really very interesting. I'm glad to have that information, but please wait in the anteroom. Don't go away, but wait in the anteroom. So my conscious part is sort of holding this interesting but irrelevant information on one side while I parting the grass and finding that path, and suddenly I find out what it is I'm looking for. So my conscious part was dismissing or holding all temporarily irrelevancies. Having discovered that my conscious part was then dismissing irrelevancies, I then found the irrelevancies fell into two main classes. All the experiences which I'm trying to recall and identify to feed in here, all experiences which are too large and too infrequent to in any way be synchronizable with the magnitude that I'm considering. And all the experiences I've had which are too high frequency, too minute to in any way have worthwhile magnitude at the size of it. So I find that really is tuning. There's a much too greater wavelength and much too small a wavelength. This is really a discrete one. Now, furthermore, about our experiences, I'm dismissing experiences that are irrelevant. So there's a macrocosmic and a microcosmic group. Now, experiences are inherently omnidirectionally observed. That is, our Earth is revolving, you and I are pivoting, revolving, we're looking in all directions. So when I take my total experiences, they are an omnidirectionally position in respect to me. Therefore, the irrelevancies which are too large and too infrequent, I dismiss outwardly, omnidirectionally. And the ones that are too high frequency, too small, I dismiss inwardly. I discover then that the consequence of my conscious subscription intuitively to this preoccupation is important, and my conscious attempt then to put aside the irrelevancies has then taken all my experiences and put them into two main groups, all the experiences outside and all the experiences inside, and a few of the experiences which are lucidly irrelevant to each other. I discovered then what I call a thought is a relevant set. And this relevant set defines an insideness and outsideness. And I said, all right, how many stars would it take to produce an insideness and outsideness? Well, 2 stars do not. They have betweenness, not insideness and outsideness. And 3 stars have betweenness, but no insideness outside. They only define a plane, there's no thickness. Not till I get 12 stars, I have insideness and outsideness. So I said, this is really very, very exciting. This would be, I gave the name then of a conceptual subdivision of universe. I called it a system. And a system, I said, subdivides all the universe into all the universe outside the system, all the universe inside the system, and a little bit of the universe, which is a system which does the subdividing. There's got to be a very, I'm really terminal condition here, absolutely terminal. And this gave me great power of definition. So this is a thinkable set, and the minimum is a tetrahedron. Now, a tetrahedron becomes really very, very fascinating. In that relationship, I then also went into developing definition of the word structure. Because I felt that understandings and interrelationships of, incidentally, the 4 points had 6 interrelationships. It's quite a different number. One's a prime number 2, the other's a prime number 3. There's beautiful arithmetical put-ins here. The number of relationships, which you have to find to understand is finding all the relationships, was something other than the numbers of the stars. That's one reason why understanding would not be true. So here's a very important synergetic phenomenon going on. Now, structure. I found engineers, scientists did not have a definition of structure. They talk about structures, but they don't have a definition of structure. And I want to arrive at my structural definition experientially. I'm going to make a necklace. I find necklaces consisting of tubes. The surface may be quite fancy, outside of the tube, but inside is the tube through which we have then a continuous cord, and the necklace comes back to itself. It's a finite closure back upon itself, not it. I find that the matter, I'm going to pay no attention to the exterior decoration of the beads. I'm just interested in the tube parts. So I'm just going to deliberately take tubes. And I'm going to take a number of tubes of the same length, which is easy. So I'm going to take a number of aluminum tubes, a 1/4 inch in diameter and about 9 inches long, easy to see in the room here, and run Dacron cord through them. I'm going to make a very long necklace. We find we can drape it all around the room. It is characterized by its transformability, mutability. And then looking at the necklace, observing very carefully what goes on, I find none of the tubes are changing the length, nor are any of them bending. Whatever's going on here that makes possible all these changes of shape is not to do with the tubes themselves. Something between the tubes are the angles, or where the tension cable runs between them. So the cable doesn't have to necessarily go through. I can make it fast from end to end of the tube. It becomes really a fixed push-pull member with this flexible corner. So it's the angles that are changing. So because it isn't the tubes, I begin to take the tubes out one by one deliberately to see what kind of effects I get. First, I find that if there are even numbers of tubes in the necklace, it'll make a wave, positive, negative, valley, peak. But if I have odd numbers, then it gets where it's bulky and gets up and has a plateau at some point and so forth. Then I keep on taking out beads, and I finally get down to where I only have 6 beads left, 6 of these tubes. And I've draped it over my shoulders at 9 inches, 9 inches, 9 inches down front. There's a U in front of me here, a U down my back. All right, I take out one more. I only have 5. So I have a V in front here and a U down my back. I take out one more. I only have 4. I have a V in front and a V down my back. Drapes over my shoulders. I take out one more, and I only have 3. That's the minimum polygon. And for the first time, it does not flex. It is what you and I call a triangle. Now, there are 6 parsecs. There's 3 independent tensions and 3 independent compressions. And they are 6 independents are interacting to produce a stable pattern. So this begins to getting pretty close to being able to define a structure. It is a complex of events that interact to produce a stable pattern. Then I find that the only polygon that does stabilize is the triangle. And it is the minimum polygon. It cannot have of 2 sides. So I find that the minimum polygon is the stable. And it is if it exists experientially, it's going to then consist of, maybe I've draped this something on the board and fastened it, but the board, when I get down and find is a compression member. These constituents in there are the minimum that I give it to. These push-pulls. So I say a triangle is structure and a structure is triangle. And that's that. And this, in a sense, was very well known to the ancients, so that we have the trestle, the traceness, the truss. So we see men doing lots of things with other kinds of polygons and stabilizing them with little gusset plate triangles with enormous leverage against them. Very unfair to them. Anyway, nature does things the most economical way, so she would not do it in that uneconomical way of having leverage advantage against a joint. Now, next thing. Triangle is structure, structure is triangle, and I come then to the minimum system of universe and consists of 4 triangles. So not only it is a minimum system, it is a minimum structural system. It's an absolute limit case all the way through. And comes, you don't need anybody mark your paper, because you really are dealing absolute first X, Y, Z coordinate. You cannot have another dimension that is get it perpendicular to the system that is not parallel to one of the lines already introduced. And they said you can't make it, therefore, because nature is using 4th power quite clearly with black body radiation, she is not using models. Therefore, we are exempt from now on from having to explain nature does not use models. This is the middle of the 19th century, and so for about a century and a quarter, we've had science flying on instruments, not looking out the window anymore. There's nothing to look at. For this reason, then, we have this extraordinary gap between the scientists who had less than 1% of scientists, and C.P. So said the great gulf between the science and human continually breaks. And that really the whole of our society breaking down because society doesn't really know what a science is. Participation. Therefore, I'll tell you what I've been working on and giving to you here became very interesting to me. Back in the, even before World War I concluded that nature, I said, doesn't have a department of mathematics or physics and chemistry, so we have to have department meetings to know what to do. She only has one department, and she has a beautiful coordinating system. And I see that chemistry shows me she associates and disassociates in a whole rational number. It's H2O, not H pi O. So I said, I think of all the irrationals that have appeared in man's in the XYZ centimeter, gram, second, and so forth systems have all occurred because man came in the attic window instead of the front door and has been trying to measure everything with an attic window or the wrong edge of it instead of the diagonal of it, whatever they're doing. So I said, I think that it could be, we might find nature's coordinate system. And if we could find it, we might really be able to bring together the chasm between the human and the scientist. So that's the very essence of all the things I'm really communicating to you all here, that we've stayed conceptual all day. I really had to go to the board very, very little here. And that was highly conceptual. Now, I introduced the word precession to you, the effect of bodies in motion on other bodies in motion, producing 90 degrees. When man took a magnet, had a coil of copper wire, that's a coil of copper wire, and it has meters on it, there's no current in it, it's just a copper wire. It takes a magnet and approaches the coil, and immediately, precessionally, he's going this way, produces at 90 degrees a circuit, and current in it. And that sets up a field, and the field resists the magnet, says don't come any further. If he stops moving the magnet, the juice stops. If he starts pulling the magnet away, it immediately starts the coil, juice going the other way, and sets up a field, says don't go away, pulls it back. That's a pure precession. Just exactly as you drop the stone in the water and start to circle out that way. And the precession is regenerative, so it starts this way, which begets this way, and this way begets that way, and there's your wave going out there. As you get into precession and conceptuality, very much seems very obscure, suddenly begins to be seems very, very utterly acceptable to your personal experience base. I'm now going to pull away from this vectorial geometry, and I want you to have a sense of hierarchy and intertransformability and understanding that all the basic structures intertransforming one with the other, and go into, come back to the earlier part of the evening trying to think I want you to think of the biggest patterns. We've gotten into ability to think independent of size, which is even better. We have generalization, conceptuality, independent of size. And I'm going to come just to looking at our own little planet. And I spoke earlier this evening about it taking my father 2 months to go from Boston to Buenos Aires, and three months to go from Boston to Bombay. And I'd like to introduce some maps for you, because again, I find we have very powerfully conditioned reflexes. So I'm going to now introduce the next basic slide. And this next basic slide is something you're very familiar with. We call it the Mercator Map. This is what they have in all the schools and all the colleges, and keep on having it. This is the world. And in that picture of the world, you'll find the, look at, I'm a little in the way of Australia, but I want you to look at Greenland and Australia behind my neck. Greenland is apparently 3 times the size of Australia. Very good. And any tax handy? That is very good if we could. Oh, that's fine. So we see on the left-hand side Russia, and 25,000 miles away over on the right-hand side we see some Russia. They're only 5 miles apart, but they look to be 25,000 miles apart. And it has no Antarctic at all. And there's this absolutely enormous amount of water up in the northern section, apparently, as there is in the south. This is the way man has really been. He used to sail east and west in an water-ocean world. He could not transfer cargoes at sea. He had to go to harbors. There were not many harbors, and this is really a pattern of harbors. Of the East Coast with New York and Philadelphia, pretty good, but New York by far the best. Boston fairly good, and Chesapeake, and the West Coast, San Francisco, Seattle, approximately nothing else. And he had relatively few ports on the other side. So all the great traffic was between those. The integration of the earth was by water to the harbor cities, and it was east-west world, sailing pretty much within the tolerable latitudes. We don't get too cold and so forth, and using much of the trade winds. May I have the next picture then? I think that comes up on the chart there. This is an entirely unfamiliar map to you, but it is a true map as far as distortion and shape goes, relative size. This is a map of the whole world, but it's a water-ocean world. And I think, if you don't mind, would you revolve it once more for me? With turn it one corner more, right? That's it, once more. Excellent. In the upper right-hand corner, you see Asia. You see India, China, and Asiatic Russia. And the upper left-hand corner, you see Europe and Africa and the Middle East. The lower, this is a propeller blade, and the lower, you have that South America, and then North America at the very, very bottom. That doesn't, the vanity of people in America makes it look sort of, we're upside down, as they say, because there's no up and down in the universe, so we're not upside down. And it happens that the upper right-hand corner, there are 52% of humanity. And in the upper left-hand corner, there are 29% of humanity, and down here, we only have 6% in North America. So the big show, the upper right-hand corner is what Kipling called the East, and the upper left-hand corner is what he called the West. And he said, East is East and West, they never trained shall meet. The Americans were not in the show at all. They were more recently discovered, and they were not really counting in that kind of a way of thinking about things. This is a very much more important map than you can think about. It happens that 85% of all the land is north of the equator. 3/4 of the earth is water. 85% of it is north of the dry land, is north of the equator. 90% of the people are north of the equator. We are very much a northern hemisphere population world. And the southern hemisphere is just all this water. Now, we used to think of Atlantic Ocean and Pacific Ocean, Indian Ocean, separate oceans. And what we have here is the Earth is always revolving west to east. And as it revolves west to east daily, we have also the atmosphere. We have a northern jet stream and a southern jet stream revolving very much faster than the Earth. They sometimes get up to 400 miles an hour faster than the Earth is turning, the gases are turning. Then we have the waters of the Earth trying also to turn faster than the dry land. But in the northern hemisphere, there is a mountain range across here, so the waters do go around west to east in two different groups. There's a Bering Sea west to easting, and there's a Greenland west to easting. But in the southern hemisphere, the waters go west to east unimpeded. They get most choked at what we call the Horn, where the waters go through the Horn. And you can see the shape. Look at the Antarctic there, and between the tip of South America and the Antarctica, there's this horn formed where ice and enormous waters going through it, channeling through it. Now, this is the picture of this is the water-ocean world, in contradistinction to the land-ocean world. And this is and the people who learn then that the water leads between all the countries, the people who then exploited the remoteness of humanity, the great, I call them great powers for a very simple reason, that the law of the lands could not be enforced out on the water any further than human beings could throw projectiles. And that was so little distance, like 3-mile limit and so forth, about it. The laws of the land have never been forced on the sea. Therefore, the sea, which is 3/4 of the earth, is outside the law. And the people who lived on it were outlaws. And the top ones are called sovereigns, and the lesser ones are called the pirates. The ins are the sovereigns, and the outs are the pirates. And they often reverse their position. So the great exploiters, then, of the remoteness of humanity, the integration, the synergetic wealth that is generated by bringing resources remote from one another. This is the pattern of it, because there was around the south then the merry-go-round. I say not a very merry-go-round, but it was an enormous dynamic go-round from west to east. And you got down on that water, and if you could stand it, your ship could take it. You go zooming from the Pacific into the Atlantic, and zooming from the Atlantic into the Indian Ocean, and vice versa. It was a great turntable, and it became then the most economical way to get from here to there. Because once you load your ship, you can go to any place in the world. This was the key to going anywhere in the world. The English call the British Empire. This is a map of the British Empire, with 90% of humanity out in the tips of the propeller there, not knowing what's going on at all down here. They guarded the tip of South America, the tip of South Africa, and they guarded Australia and New Zealand. They guarded the merry-go-round. This is the pattern that Admiral Mahan discovered. Became very famous in the American Navy because he was suddenly introduced to the American Navy the fact that the British discovered long ago there's only one ocean, and the key of it is a great merry-go-round here. You might call it the polar go-round. And so that is the remoteness of the humanity when I checked into this picture, what was natural to me, and east is east and west is west, no change for me. May I have the next one, please? These are the same map pieces, and these map pieces, as you can check by folding them on the edge, and they make the icosahedra, they come around, you find it in complete agreement with any globe that you can compare. You will find no visual discrepancy whatsoever in relative shape or size or interrelationships. We're now looking then the same pieces rearranged to be what I call the land world. Now the land is at the center, the water is at the center before, now the land is. We have here all the dry land of the earth without any break in any of the continental contours that you had in the Mercator, without any distortion. And on it, then, we have a very interesting set of conditions. If you would rotate that once more and have North America at the top. North America at the top, sir. Once more, that's it. I'll just call this then, the Mercator was an east-west world, and that the east is east and west-west, the traffic was an east-westing. This is suddenly a north-south world. And on this map, you'll find that something very fascinating happened. In 1961, utterly unpredicted by anything in history, 3 jet airplanes suddenly carried more passengers across the Atlantic than did the Queen Mary in a fraction of the time and a fraction of the cost. In 1961, the ship became obsolete as the way in which man got from here to there around his world. And this is not as yet really serious, so those ships looking for cruise ships, whatever it is all over. And with it, all the railroad, the east-westing railroad is gone. So we have great ports like New York, where humanity used to come in, enormous real estate investments there, San Francisco, so forth. And now there's nothing there except to try to get conventions to try to keep going. And the people who left their farms, they're all piling in. And so we have a momentary great mess of really no raison d'etre whatsoever. We have then suddenly this north-south world. And on it, that map you're looking at now, 90% of humanity can reach each other on the shortest great circle routes without going near the Atlantic, Pacific, or the Indian Ocean. They're obsolete for our interest now except as a place to cruise. They're also very, very important when we come to food supply, but the point is that as far as all the traffic goes, this is the way it's going to go. But we have such powerful investments in the real estates in those cities that want to be east and west, that they try to resist this. But what's going on is Canada is suddenly becoming really important, because what is Canada? They have the contact with Russia and China. No distance at all. And I wanted to give you a very abrupt picture. Now, we have, and we'll show you on, you'll see it on the screen. I'd like to show the slides of the population. We have 3,600,000,000, pretty close, about 700 million people on our planet right now. So 1% would be 37 million people. Can you see on the screen, all of you? There is the water-ocean world, and on that water-ocean world, each one of those white dots is 1% of humanity. Actually located where the people are, by far the greatest concentration of people is around Bangladesh. You can see in there, there's enormous, that whole subcontinent is just extraordinary, the number of people there, China and India, Pakistan. So. Excuse me, may I have that picture back again? And upper left you see your Europe. Then if I get myself out of the way here, you see North America, very few little lights there, and very few, 4 of them in South America. This is the real emphasis of humanity. We have an integrating humanity. Yesterday man inherently divided, now man inherently integrated. Nothing could be more abrupt kind of change historically, coming in the big patterns I've talked to you about. So, may I have the next picture again? There we'll see the land world, and where the people were deployed and remote from one another, suddenly see how close they really are to one another. And you can really see how swift this integration is just simply bound to be. I feel that I have given you now enough for tonight. It's 10:30. But the main thing was to introduce enormous big patterns that evolution, the universe is at work. The universe has an a priori integrity. There's an a priori mystery. You and I come in ignorant, helpless, naked, finding our way. We have gained enough understanding of experiences to discover that, as the Oxford Dictionary makes it very clear, about 100,000 nuances of common experiences that so unique a nuance that they really need their own special describing word, that we've agreed on 100,000 words for those unique experiences. It represents one of the most extraordinary memorials of humanity to me, that we have those tools that I can sit here using, thinking out loud, and use those tools gained by humanity over all those millions of years of communicability. So I see then these very beautiful big things happening, and we will pursue it from there. But I think I've introduced to you a grand strategy of problem solving. I've wanted to think about why are humans here, why do they have that beautiful mind, and why do they have access to the great principles of the universe itself, of the great design, nothing else we know has access to. I say we're common to all human beings in all history, completely independent of any ethnic difference, whatever it may be. Problems, problems, problems. That we're here for problem solving, not to have problems out of the way, some stupid, sublime, something called peace. We're here strictly for problem solving. And the better you get at it, the more problems you're going to get to solve. And we find the games played by humanity, they knock out a fly, get randomness and convert it to order as quick to be. The whole game is convert to order, to comprehend, understand. And in this transition we're going through, we're going to a great deal of that, and then further sections of what goes on, what is politics and what. But I think tonight then we have the prime ingredients. I think I've introduced a good problem strategy solving capability. What systems really is. We have a system which you don't have any parameters are going to get accidentally left out, and I think I've introduced enough to have confidence with me in seeking more and more of these big patterns, all the time really then being able to exempt man, not taking him too seriously. I'm quite confident that the star sun is not saying the other stars are not going to keep life going on that planet, they haven't paid their bill. I don't think that the universe is talking any such nonsense, and what we're out to really discover we can is how the universe really does operate, why we are here, and how we begin to participate in the big game of universe itself, rather than a game we've been playing on our planet Earth, which is really quite unrealistic and been highly distortable. Thank you.